When dealing with 10 condos that do not share a common wall, they are generally considered 10 separate services. This means each condo will require its own individual meter. Now there are several options available for metering this type of arrangement. Firstly, individual meter cans. Each condo could have its own meter can located near the service entrance. This is a traditional approach where each unit has its own dedicated meter and disconnect. Secondly, a centralized meter pedestal. In this setup, a central pedestal can be installed outside, with each condo's meter mounted on it, similar to a commercial meter panel. This consolidates all the meters into one location, which can simplify reading and maintenance. Thirdly, remote metering system. Consider advanced metering infrastructure, or OMI, which allows for remote monitoring and data collection from each individual meter. This is a more modern approach that can provide detailed energy usage data and enable remote disconnect or connect capabilities. Since you have multiple services, you will need one main disconnect for each service. This translates to a total of 10 main disconnects. These disconnects should be located near the service equipment for each condo. You will also need a 10-gang meter center to accommodate all the meters. The meter center can be installed near the main disconnects or in a central location such as a utility room. This meter center provides a consolidated location for all the meters, making it easier for the utility company to read them and maintain the system. Each meter will need its own conduit and wiring to connect it to the service equipment. This ensures that each condo has a dedicated circuit from the meter to its electrical panel. If necessary, demand-limiting devices can be installed at the service entrance for each condo to manage peak energy usage. These devices can help prevent overloading the system and reduce demand charges from the utility company. It is essential to check with the local utility for specific requirements and regulations regarding metering and main disconnects. Utility companies often have specific standards for meter installations and disconnect locations, so it's crucial to adhere to these guidelines. When planning the electrical service for these condos, several factors need careful consideration. Firstly, the electrical load calculation for each condo unit. This calculation determines the minimum service size required for each unit, ensuring that it can handle all the electrical appliances and devices. Secondly, the National Electrical Code, or NEC, requirements. The NEC provides detailed guidelines for electrical installations, covering everything from wiring methods to overcurrent protection. Compliance with the NEC is essential for safety and code compliance. Thirdly, the available space for equipment. Ensure that there is enough space to install the meter center, disconnects, and other electrical equipment. Consider both indoor and outdoor space requirements. Fourthly, accessibility for maintenance. The meter center and disconnect should be easily accessible for maintenance and repairs. This will make it easier for electricians and utility workers to perform their job safely and efficiently. Fifthly, coordination with the utility company. Work closely with the utility company to ensure that the electrical service meets their requirements and that the metering is properly installed and configured. The grounding and bonding system is also crucial. A proper grounding and bonding system is essential for safety, protecting against electrical shock and preventing equipment damage. Make sure that the grounding system is properly installed and tested. Surge protection is a consideration as well. Surge protection devices can help protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Consider installing surge protection at the service entrance or at individual electrical panels. The placement of the meter center and disconnect should be carefully planned. Consider factors such as aesthetics, accessibility, and security when determining the location of these components. The wiring methods used for the service entrance conductors should comply with the NEC. Common wiring methods include conduit, cable, and busware. Select the appropriate wiring method based on the specific application and local code requirements. The overcurrent protection devices, such as circuit breakers or fuses, should be properly sized and installed. These devices protect the electrical system from overloads and short circuits. The labeling of the electrical equipment is important. All electrical equipment, including meter centers, disconnects, and electrical panels should be properly labeled with clear and concise information. This helps ensure safety and facilitates maintenance and repairs. Consider future expansion when planning the electrical service. If there is a possibility of future expansion or increased electrical load, it is important to design the system to accommodate these changes. This may involve installing larger service conductors or providing additional capacity in the meter center. The use of energy-efficient lighting and appliances can help reduce energy consumption and lower utility bills. Encourage condo owners to use energy-efficient products whenever possible. Regular maintenance of the electrical system is essential for safety and reliability. Schedule regular inspections and maintenance to identify and address any potential problems. The electrical service should be inspected by a qualified electrician to ensure that it is installed in accordance with the NEC and local codes. This inspection should be performed before the service is energized. The utility company will also typically inspect the service before connecting it to the grid. Safety is paramount when working with electrical systems. Always follow safe work practices and use appropriate personal protective equipment. If you are not qualified to work on electrical systems, hire a licensed electrician. Always to energize the electrical system before working on it. Use a voltage tester to verify that the power is off before touching any wires or equipment. Never work on electrical systems in wet or damp conditions. Keep the work area clean and free of clutter. Use insulated tools when working on electrical systems. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of the potential hazards of working with electricity and take steps to mitigate these hazards. Follow all applicable safety regulations and guidelines. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician. The electrical system should be designed and installed to meet the needs of the condo owners. Consider their lifestyles and energy usage patterns when designing the system. Provide adequate lighting and power outlets to meet their needs. The electrical system should be reliable and durable. Use high-quality materials and components to ensure that the system will last for many years. The electrical system should be easy to maintain. Design the system so that it is easy to access and repair. The electrical system should be aesthetically pleasing. Conceal wiring and equipment whenever possible to create a clean and uncluttered look. Consider the environmental impact of the electrical system. Use energy-efficient products and design the system to minimize energy consumption. The electrical system should be cost-effective. Balance the cost of the system with its performance and reliability. Obtain multiple bids from qualified contractors before selecting one to install the electrical system. Review the bids carefully to ensure that they include all of the necessary work and materials. Check the contractor's references and qualifications before hiring them. Make sure that the contractor is licensed and insured. Obtain a written contract that outlines the scope of work, payment terms, and warranty information. Monitor the contractor's progress to ensure that the work is being done properly. Conduct a final inspection of the electrical system before making final payment. Address any issues or concerns with the contractor before closing out the project. Keep all documentation related to the electrical system, including permits, inspections, and warranties. This information will be helpful for future maintenance and repairs. By following these guidelines, you can ensure that the electrical service for the 10 condos is safe, reliable, and meets the needs of the condo owners. Remember to always consult with qualified professionals and adhere to all applicable codes and regulations. Think about the long-term costs associated with the metering options. While a remote metering system might have a higher upfront cost, the long-term benefits of reduced manual meter reading and enhanced data collection might make it a more cost-effective option. Consider the impact of the metering system on the property value. A well-designed and modern metering system can enhance the value of the condos. Ensure that the metering system is compliant with all applicable accessibility standards. This is particularly important if the meter center is located in a common area. The metering system should be designed to prevent tampering and unauthorized access. Consider using tamper-resistant enclosures and locks. The metering system should be designed to minimize the risk of electrical hazards. Ensure that all wiring and equipment are properly grounded and protected. The metering system should be designed to be compatible with the existing electrical infrastructure. This will help to minimize the cost and disruption of the installation. The metering system should be designed to be scalable and adaptable to future changes. This will allow the system to be easily expanded or modified as needed. The metering system should be designed to be environmentally friendly. Use energy-efficient components and minimize the use of hazardous materials. The metering system should be designed to be easy to understand and use. Provide clear and concise instructions for condo owners and maintenance personnel. The metering system should be designed to be visually appealing. Conceal wiring and equipment whenever possible to create a clean and uncluttered look. Consider the impact of the metering system on the overall aesthetics of the property. Choose a metering system that complements the architectural style of the condos. The metering system should be designed to be secure against cyber attacks. This is particularly important for remote metering systems that are connected to the internet. Implement appropriate security measures to protect the system from unauthorized access and data breaches. The metering system should be designed to be resilient to power outages. Consider using a battery backup system to ensure that the meters continue to function during a power outage. The metering system should be designed to be easy to troubleshoot and repair. Provide detailed documentation and training to maintenance personnel. Keep a supply of spare parts on hand to minimize downtime in the event of a failure. The metering system should be designed to be compliant with all applicable data privacy regulations. This is particularly important for remote metering systems that collect personal data. Obtain consent from condo owners before collecting and using their data. Implement appropriate security measures to protect their data from unauthorized access. The metering system should be designed to be sustainable over the long term. Use durable materials and components that will last for many years. Implement a regular maintenance program to ensure that the system continues to function properly. The metering system should be designed to be a valuable asset to the condo community. By providing accurate and reliable metering data, the system can help condo owners to manage their energy consumption and save money. Remember that you may need to consult National Electrical Code Table 310.15b16 for conductor ampacity based on insulation type and ambient temperature. This table provides guidance on the allowable ampacity of conductors based on their insulation type and the ambient temperature in which they are installed. The allowable ampacity of conductors may need to be derated based on the number of current carrying conductors in a raceway or cable. National Electrical Code Section 310.15b3 provides guidance on derating conductor ampacity. The overcurrent protection devices should be sized no larger than the allowable ampacity of the conductors they protect. This helps to prevent overloads and short circuits. The grounding and bonding system should be installed in accordance with National Electrical Code Article 250. This article provides detailed requirements for grounding and bonding electrical systems. Surge protection devices should be installed in accordance with National Electrical Code Article 280. This article provides requirements for surge protection devices. All electrical equipment should be listed and labeled by a nationally recognized testing laboratory, such as Underwriters Laboratories, or all. This ensures that the equipment meets safety standards. The electrical installation should be inspected by a qualified electrical inspector to ensure that it complies with the National Electrical Code and local codes. It's also important to consider future technology advancements. As technology evolves, newer and more efficient metering solutions may become available. Designing a system that can be easily upgraded or integrated with future technologies can be beneficial in the long run. Consider the use of smart meters with advanced communication capabilities. Smart meters can provide real-time data on energy consumption and enable features such as remote disconnect/connect and demand response programs. Research available grants and incentives for energy-efficient metering systems. Some utilities and government agencies offer financial incentives for installing energy-efficient equipment. Explore options for integrating the metering system with building management systems. This can provide a comprehensive view of building performance and enable automated control of energy-consuming devices. Consider the use of renewable energy sources, such as solar panels, to offset energy consumption. The metering system should be able to accurately measure the energy generated by the renewable energy sources. Think about the potential for energy storage systems, such as batteries, to store excess energy generated by renewable energy sources. The metering system should be able to manage the charging and discharging of the energy storage systems. Consider the impact of electric vehicle charging on the electrical system. The metering system should be able to accommodate the increased demand from electric vehicle chargers. Explore options for providing incentives to condo owners to reduce their energy consumption. This can include offering rebates for energy-efficient appliances or providing feedback on their energy usage patterns. Think about the potential for using the metering data to identify and address energy waste. By analyzing the data, you can identify areas where energy is being wasted and implement measures to reduce consumption. Consider the use of sub-metering to track energy consumption by individual appliances or devices. This can provide more detailed information on energy usage patterns and help condo owners to identify opportunities to save energy. Explore options for using the metering data to create a virtual energy audit. This can provide condo owners with a personalized assessment of their energy consumption and recommendations for saving energy. Think about the potential for using the metering data to participate in demand response programs. Demand response programs provide incentives to reduce energy consumption during peak demand periods. Consider the use of open standards and protocols for the metering system. This will ensure that the system is compatible with other devices and systems. Explore options for using the metering data to improve the overall efficiency of the building. By analyzing the data, you can identify areas where the building can be improved to reduce energy consumption. Think about the potential for using the metering data to create a more sustainable community. By promoting energy conservation and efficiency, you can help to create a more sustainable community. Consider the use of a centralized data management system for the metering data. This will provide a single point of access for all of the metering data. Explore options for using the metering data to create a public dashboard that displays energy consumption information. This can help to raise awareness of energy consumption and encourage condo owners to save energy. Think about the potential for using the metering data to create a competition among condo owners to see who can save the most energy. This can be a fun and engaging way to promote energy conservation. Consider the use of gamification techniques to encourage condo owners to save energy. This can include awarding points or badges for achieving energy-saving goals. Explore options for partnering with local organizations to promote energy conservation. This can help to reach a wider audience and leverage their expertise. Think about the potential for using the metering data to track the progress of energy conservation efforts. This can help to demonstrate the effectiveness of the efforts and justify further investment. Consider the use of a comprehensive energy management plan for the condos. This plan should outline the goals for energy conservation and the strategies that will be used to achieve those goals.